Hi, hello, and welcome to Math at a Go. Here we are in the fourth session of our sixth day progressions under 18-day action plan. Let us see what we have today. The 10th problem says find the 10th and nth term of GP 525 125. 525 125. He says it's GP. Let us see what a GP is. Before I tell you what a GP is, let me tell you an interesting story. Long, long ago, around 1500 years ago, a very intelligent guy invented the game called chess. Very much interesting, the battle of kings and soldiers. And he went to present the gift to the king of his kingdom. And the king was very much happy looking at the game and the rules, and the game really thrilled the king like anything. So he was happy and wanted to give something to the inventor of the chess. So he announced, "Oh, my dear friend, whatever you want, I'm ready to give. So please ask what you want," he said. We all know the game of chess has 64 squares. So the inventor of the chess also wanted the gift in terms of the chess. So he asked the king, "Oh, my king, I do not want much more than anything apart from this chess. So please put one grain of rice in the first square of the chess box. And in the next square, please double the number of grains that you put in the first box. So in the second box, you will be putting 2 grains of rice. And in the third box, you will be putting 2 twos of 4 grains. And in the fourth box, you will be putting 4 twos of 8 grains." Like that, keep on doubling the number of grains that are there in the previous square. So like this, go on putting the grains until the 64th square, and whatever are all there, those grains, please send them to me, said to the king. The king was baffled and thought this fellow to be a mad fellow, because when the king was ready to reward him with anything, how could he ask such a simple thing, he thought, and he ordered the treasurer to give out the gift to the inventor. And time passed on. After 2 days, the inventor went back to the king and asked, "Sir, I did not receive my reward." The king got angry and called the treasurer and asked, "Why has the man not been paid the reward? I have already ordered. Should you be punished or what?" asked the king. But the treasurer simply asked for an excuse and said, "Oh, my king, it is not possible to pay him so many grains as he asked." The king wondered, "What? We are such a rich country, and can't we pay simple rice grains that he asked that could be simply put in the squares?" The treasurer smiled and said, "Yes, my dear king, even the whole of the rice that we grow in a year is not sufficient to pay him," she said. And the king was surprised. So what happened later on, not of a concern to us, but the wonder is, you see, when you go on doubling things, it goes on like anything. And that is what is happening now with corona. It is just the same way as the number of corona cases that are increasing in this world or in this India. They were very little in number in the beginning, and as the time is passing on, they are doubling and multiplying. And today we are with more than 2 lakh cases in India today. And what is happening with these corona cases and what happened in the case of number of grains is all about the geometric progression. So let us see what a geometric progression is. In arithmetic progression, we were adding a fixed number to the previous number to get the next term. Yes, sir? So to get the next term, we were adding some fixed number to this one. Like this, we went on adding. So that gave us arithmetic progression. And in geometric progression, instead of adding, we multiply it. That may be a fraction or a number or whatever it is, we multiply it. So the series of numbers so obtained by multiplying the previous term by a fixed number. This doesn't apply to the first term. First term is an exception. So except first term, the next terms are obtained by multiplying the previous term by a fixed number. This is called a geometric progression. Let us see. For example, let A be the first term of a geometric progression. As we call, we will name it A1 because it is the first term. Now you multiply it by some other number to get A2, and you multiply this one with the same number with which you multiply this to get this one. So we'll multiply this one with the same number as you multiplied this one. So then you will get the third term A3. Then A4, like this you will go on getting the terms. That means you multiplied this one by something and you got this one. This one by something and you got this one. This one by something and you got this one. That means what number you are multiplying with, can we know? Yes. If you divide this one by this one, so if you divide A2 by A1, you must know what number you multiplied with to get this one. Yes or no? In the same way, if you do A3 by A2 also, you will get the same number. And in the same way, if you do it by taking A4 by A3 also, you will get the same value. And because you multiplied with the same number, all these will be equal. So we will get that number by which you multiplied the previous term to get the next term. So this number we called the common difference in arithmetic progression, because we were adding that created the difference. Now here, because we are multiplying, what is happening? It is creating some difference, but this is not difference, this is the ratio it is creating. So this is common for all, therefore we call this as common ratio represented by R. That means A2 by A1 must be equal to A3 by A2, that must be equal to A4 by A3, and that value we call as common ratio represented by the small letter R. So to find whether a series is an arithmetic progression or geometric progression, we have to test this. Either is A2 by A1 equal to A3 by A2 and equal to A4 by A3, or A2 minus A1 is equal to A3 minus A2 is equal to A4 minus A3. So depending on this, we will decide whether it is an arithmetic progression or a geometric progression. Now let us go into some more details. Let A be the first term of the geometric progression, and you are multiplying it by R, so the next term will be AR. So A1 is nothing but A, A2 is nothing but AR, and again you multiply it by R, you will get AR square. So A3 is AR square. Then what will be the A4? So this will be multiplied by one more R, so this becomes AR cube. If you observe properly, the first term has no R's, 0 R's. The second term has 1 R. The third term has 2 R's. The fourth term has 3 R's. A is always common, of course. That means if we want A100, can we guess what will be the term? It will be AR raised to the power of 99, because 1 R will be less than the roll number of the term. Therefore, A100 is equal to AR to the power of 99. So this is how we write. Now if we want nth term, because we do not know what term will be asked, let us do it for any generalized term. So let us think we want an nth term defined by an. So what will be the term? So there will be na common, and r will be raised to the power 1 less than this one, so n minus 1. So this is the general term of a geometric progression. In arithmetic progression it was an is equal to a plus n minus 1 into d, and here in geometric progression it is ar to the power of n minus 1. So this a is common, n minus 1 into d here, r to the power of n minus 1 here. So n minus 1 is always the same. It is either multiplied or raised to the power. That is only the difference. Because we are multiplying, it is becoming the power. Because we are adding here, it is being multiplied here. That is what we should notice. When you compare and study, it becomes easier for you. So let us now get into the problem. The question is, find the 10th and nth term of this GP. So this is the GP. So from this GP, what can we say? A is equal to 5. Yes or no? Yes, this is the first term. A is equal to 5. Then what about R? In case of arithmetic progression, we were subtracting A3 minus A2 or A2 minus A1. That way we got the common difference. Here in geometric progression, we have to divide A2 by A1 or A3 by A2. Then we will get a common ratio. So let us see. R is equal to A2 by A1 is equal to 25 by 5. This gives you 5. Therefore, A is equal to 5 and R is also equal to 5. Now, with this, we have to go ahead. Why should we find this? As discussed in the previous session, A is the common core, very important for any progression. and the common difference or the common ratio is next most important to decide course of the progression. So A and R are compulsory to do the proceedings of any problem in progression. So we will always find A and R. Now as a part of this we found this one. The question is we have to find the 10th term. So what is the 10th term? To decide the 10th term we should know the general term formula. An is equal to AR to the power of n minus 1. This is what we know already. Now if you want A10 it will be A10 is equal to A 5 into R to the power of n minus 1. What is R? It is 5. 5 to the power of n is 10. 10 minus 1. So this becomes 5 into 5 to the power of 10 minus 1 is 9. So this can be written as 5 to the power of 10. Therefore A10 is equal to 5 to the power of 10. Don't worry about its value. It will be a very big number. You need not calculate. Simply put it in terms of powers. That is enough. Therefore 10th term is nothing but 5 to the power of 10. Now he is also asking the nth term. How do we find the nth term? Yes, we know. Generally this is the nth term for any geometric progression. Then what about the nth term for this progression? We have to substitute A is equal to 5 and R is equal to 5 in this formula. Then we will get the nth term for this specific progression. So let us substitute. Now the formula is An is equal to AR to the power of n minus 1. So An is equal to A is 5 and R is also 5 to the power of n minus 1. Now this becomes 5 to the power of 1 into 5 to the power of n minus 1. Because bases are same, powers can be added. So this becomes 1 plus n minus 1. Minus 1, this one gets cancelled. So this becomes 5 to the power of n. Therefore An is equal to 5 to the power of n. So whichever term you want, that has to be the power to the base of 5. That will be the term. So if you want 10th term, it will have 5 to the power of 10. Yeah, it is the same. If you want second term, it will be 5 to the power of 2. 5 square 25. If you want third term, it will be 5 cube. 5 5s are 25. 25 5s are 125. Yes, this is so. So the nth term is 5 to the power of n and the 10th term is 5 to the power of 10. That's it. Very simple. Coming to the 11th problem now. The fourth term of a GP is 2 by 3. The fourth term in the sense A4 is equal to 2 by 3. And the seventh term is 16 by 81. The seventh term is 16 by 81. Find the GP. We have to find the GP. What is important to find the GP? You should know the first term A and the common ratio R. So let us see how we can find that. We know A4 is equal to 2 by 3. But A4 is nothing but AR to the power of 4 minus 1. That is nothing but AR cube. Therefore, AR cube is equal to 2 by 3. Let this be equation number 1. The seventh term in the sense it will be AR to the power of 7 minus 1, which means it will be AR to the power of 6. Therefore, AR to the power of 6 is equal to 16 by 81. Now let this be equation number 2. If you remember properly, this second problem is exactly the same as this 11th problem. Determine the AP whose third term and 7th term is given. So third and 7th term are given. We found AP. How? We made an equation. Third term in the sense A plus 2D. 7th term in the sense A plus 6D. So they both were equal and they were solved using linear equations. Now also we have the same. We have two equations, but here we do not add them. We divide one by the other. Why divide one by the other? It's all about multiplication and division. So by adding we do not get anything fruitful. So we'll go for division of one by the other. Now which equation to divide by which? You can divide 1 by 2 or 2 by 1. Whichever is comfortable you can do it. There's no rule like we should divide only the second one by the first one or only the first one by the second. There's no rule as such. But for easy thing, the bigger one to be divided by the smaller one. So this is bigger one, we'll divide this one by the smaller one. That's it. So dividing equation number 2 by equation number 1. So equation number 2 says AR to the power of 6 is equal to 16 by 81. Now this has to be divided by this one. So AR cube is equal to the same, yes or no? So we need not put this one here separately. So this will be like this. So 2 by 3. Now what happens if you simplify? A get cancelled. So this becomes r to the power of 6 minus 3. Why? A to the power of m by a to the power of n is equal to a to the power of m minus n is equal to, this becomes 16 by 81 as it is, and this will become its reciprocal, 3 by 2. If you see properly, this will be r cube, which will be equal to 3 ones, 3 twos, 3 sevens, 2 ones, 2 eights. So this is nothing but 8 by 27. And if you still more think, it becomes like 2 by 3 whole cube. Yes or no? 2 cubed is 8, 3 cubed is 27. So both of them cubed, therefore I am writing like this. Now applying cube root on either side, we get r is equal to 2 by 3. You can simply cancel like this. The same powers can be cancelled on either side. So r is equal to 2 by 3. Therefore we found r is equal to 2 by 3. Now what? As discussed, we should know both a as well as r. R is found, then how to find a? Simple, substitute in any of these the value of r, you will get the value of a. Let us see. Let me substitute r is equal to 2 by 3 in equation number 1. So substituting r is equal to 2 by 3 in equation number 1. So the equation is ar cube is equal to 2 by 3, and a into 2 by 3 whole cube is equal to 2 by 3. So this can be written as a is equal to 2 by 3 by 2 by 3 whole to the power of 3. This can also be written as power 1. Now what? Let this be a, then it is the form of a to the power of 1 by a to the power of 3. So this becomes a to the power of 1 minus 3. So you can write it as 2 by 3 to the power of 1 minus 3. In the sense, it becomes 2 by 3 to the power of minus 2. That means it is nothing but 3 by 2 whole square. If you have a minus symbol to the power, you have to make the reciprocal of the base, then that will become positive power. So now this is nothing but 3 square by 2 square. So 3 square is 9 by 4. Therefore a is equal to 9 by 4. So we found out r and a. So we can find out anything. So let us now write the GP, the geometric progression. So the geometric progression will be A1, A2, A3, A4 and so on. So A1 is nothing but A, this is nothing but 9 by 4. A2 is nothing but AR to the power of 1, which means 9 by 4 into what is R? 2 by 3. So 2 ones, 2 twos, 3 ones, 3 threes. So this becomes 3 by 2. A3 is equal to AR square, which means 9 by 4 into 2 by 3 square. That means 9 by 4 into 2 square is 4 by 3 square is 9. 9, 9, 4, 4 get cancelled and this becomes 1. Now A4, the fourth term is equal to AR cube, that is equal to 9 by 4 into 2 by 3 whole cube. So if you multiply this one, you will get it like 9 by 4 into 8 by 27. So 4 ones, 4 twos, 9 ones, 9 threes. So this is becoming 2 by 3. Therefore, the geometric progression is 9 by 4, comma 3 by 2, comma 1, comma 2 by 3, comma so on. So this is the geometric progression he has asked us to find. That's it. Very simple. If you are thorough with arithmetic progression, you will definitely understand geometric progression very easily. It's all the same. The only thing is operation changes. Instead of multiplication there, we are making power. Here, the most important thing is we have to equate the powers every time. Then the problem is solved easily. Prime factorization to equal the powers plays the vital role in geometric progression. This is very important and you must learn it. The prime factorization, making the powers same, and exponential laws. These are very important. By learning which, you will be thorough. Coming to the last problem of this session. If the two GPs 162, 54, 18 dash 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 and 2 by 81, 2 by 27, 2 by 9 have their nth terms equal, find the value of n. What an interesting problem. You see there are two GPs. One is 162, 54, 18 dash 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 and there is an nth term P, let us think. And in the second GP, which is 2 by 81, 2 by 27, 2 by 9 dash dash dash, also there is an nth term which is also P. That means the nth term of this progression and the nth term of this progression, that means the roll numbers of both are same. So not only the roll numbers, but the terms are also the same. So for example, let that be 10th term. So the 10th term of this progression and the 10th term of this progression are both equal. Then find the roll number of that which is equal in both the progressions. That is the question. So let us imagine, let the term be nth term which is equal in both. So let the term be an which is equal in both the progressions. Now what happens? Let us take the first GP. From the first GP, from the GP1, what happens? 162, 54, 18 dash dash. We know A is equal to 162 and R is equal to 54 by 162. That means it is nothing but 1 by 3. So let the term be an, which is what we want, the P. So an is equal to ar to the power of n minus 1. That means a is what? 162 into r is what? 1 by 3 to the power of n minus 1. So this is what we wanted. And from the second GP, let us see what happens. The second GP is 2 by 81, 2 by 27, 2 by 9, and so on. Here also we have an nth term which is equal to this one. So from this we can say A is equal to 2 by 81 and R is equal to 2 by 27, the A2, by 2 by 81, the A1. So 2 get cancelled. So this becomes 1 by 1 into 3 by 1. That means it is 3. Therefore A is equal to 2 by 81, R is equal to 3 here. Now an is equal to ar to the power of n minus 1. That means 2 by 81 into 3 to the power of n minus 1. This is the nth term. But as per the problem, both are equal. So here we have to equate them. Let us see how we can do. This and this both are equal as per the problem. As per the given data. 162 into 1 by 3 to the power of n minus 1 is equal to 2 by 81 into 3 to the power of n minus 1. This is very important. Now what happens? Let us see. Let us get this one here. So what happens? This becomes 162 will be here only like this, and this 81 comes up. So this becomes 81 and this comes down by 2. That means whenever you get a fraction to the other side of the equal symbol, that becomes its reciprocal. So 162 into 81 by 2 is equal to 3 to the power of n minus 1. And let us get this one here. What happens? Let this be like this, 1 by 3 to the power of n minus 1. Am I correct? Right. So this is simply multiplied here and this becomes the denominator here. Now what happens? Let us see. This becomes 2 ones to 81. So this becomes 81 into 81 is equal to 3 can be written as 3 by 1. 3 by 1 by 1 by 3 whole to the power of n minus 1. Am I correct? So 81 into 81, let us put it like this only, is equal to, this is 3 by 1 and this becomes 3 by 1. Am I correct? Because 3 by 1 will be like that only and this becomes its reciprocal. So 1 by 3 becomes 3 by 1 whole to the power of n minus 1. That means 81 into 81 is equal to 3 3s are 9 to the power of n minus 1. This can be ignored simply. So this becomes 9 square into 9 square is equal to 9 to the power of n minus 1. Why did we take 9 as power? As discussed just now, it is all the logic of making the bases equal. So because 9 is here, I have tried to write it in terms of 9. Had 3 been here, I would have written in terms of 3, the base. So now this can be written as 9 to the power of 4 is equal to 9 to the power of n minus 1. In equal terms, when bases are same, powers are also same. So 4 is equal to n minus 1, which means n is equal to 5. Therefore, n is equal to 5, which means the fifth term in this as well as in this will be the same. The fifth term. Let us see, is it really so? So what will be the fifth term here? Let us see. As per this one, let us substitute n is equal to 5 here. What happens? So 162 into 1 by 3 to the power of 5 minus 1. So it will be 4. So it's nothing but 162 into 1 by 3 to the power of 4, in the sense 81. Yes or no? Now on cancellation it becomes 2. Yes or no? So the fifth term is 2 here. Now let us see what we will have here. So here the nth term is this one. In this substitute n is equal to 5. So 2 by 81 into 3 to the power of 5 minus 1 is 4. Now this becomes 2 by 81 into 3 to the power of 4 is 81. 81 get cancelled, it is 2. So in both the cases we got the same 2 as the term. That means the terms are same. Therefore what you have done is right. Therefore here the nth term, that is the fifth term, is same for both. That's it. Good luck. Have a fantastic journey.